Hi there, pre-algebra students. We're going to go over your second homework assignment here on the real number system, fractions and decimals. So this goes over our work from yesterday on converting fractions into decimals and decimals into fractions to see whether we have terminating or repeating decimals. So let's go ahead and just check and see and make sure everybody has their homework, and then we're going to go over and review and make sure that everybody understood the homework assignment okay. All right, go ahead and pause the video and do that, and then we will go over the assignment. All right, so let's go ahead and go over the homework here. So it says, number one, which of the following fractions would convert to a repeating decimal? So I'm kind of going back and remembering the little trick that I learned, that repeating decimal happens anytime I have 9 as the denominator and a single digit as the numerator. So if I look here at my choices, I see 9 as the denominator and 2 as the numerator. Well, 2 is a single digit over that 9 denominator, so I know that anytime I have a situation like that, the decimal is going to be a repeating decimal. So I just know, because of that shortcut, that mathematical shortcut, that number 1 is D. Now number 2 wants to know which of the following fractions converts to a terminating decimal greater than 1. So I can automatically cross out C, because 1/4 is the same as saying 25 hundredths. So that's not going to be greater than 1. In order to be greater than 1, the numerator has to be greater than the denominator. So in all 3 of these cases, I'm going to get a decimal that's greater than 1. I just simply have to figure out which one of these is going to be a terminating decimal, meaning that it's going to stop. So if I look at answer choice A, it is 4/3. So in order to solve this, I take the numerator and divide it by the denominator, and this will be a decimal because 4 is not going to go into 3 at all. Sorry, I did that backwards. The 3, the denominator, is going to be divided into the 4. So this is the correct. I take the denominator and I divide it into the numerator. So this still is going to end up as a decimal, but it's going to end up as a decimal greater than 1 because the numerator is bigger than the denominator. Sorry for that confusion. So 3 goes into 4 one time, and then when I multiply 1 times 3, I get 3, and then I'm going to put my decimal here, and this is a 0. So 4 minus 3 is 1, and then I'm going to bring that 0 down, and I'm going to start the long division over. 3 goes into 10. 3 times 3 times 3 is 9. 10 minus 9 is 1. I'll bring down another 0. And again, I'm getting a 0. So it seems like this is going to be repeating. 3 goes into 10 3 times. 3 times 3 is 9. So this is just going to keep giving me the same answer. So this is not a terminating decimal. This is a repeating decimal. So it's not answer choice A, because that's a repeating decimal, and the qualifier for us is that it's a terminating decimal. So now I'm going to move on to answer choice B. And again, I'm going to divide the denominator into the numerator and see whether or not we get a terminating decimal that's greater than 1. So how many times can 2 go into 7 in the number 7 halves? 2 times 3 is 6. So 2 times 4 is 8. That's too big. 3 times 2 is 6. 7 minus 6 is 1. And then I'm going to have my decimal here and a 0. Bring that 0 down. I get 10. 2 goes into 10 5 times. 5 times 2 is 10, so I'm left with no remainder. So this is a terminating decimal here, but I just want to kind of go that extra step further and make sure that I have the best choice here. So 13/11ths. So this is where I'm going to take the denominator of 11 and divide it into our numerator of 13. So if I think about how many times can 11 go into 13, it goes in 1 time. 1 times 11 is 11. 13 minus 11 is 2. Move my decimal point up there, and then I have this 0 I'm going to bring down. 11 goes into 21 times. 1 times 11 is 11. 20 minus 11 is 9. And then I have another 0 I'm going to bring down. 11 goes in to 90 8 times. 8 times 11 is 88. Get a 2, and then I'm going to bring down the next 0. And then I'm going to say 20. 11 goes into 20 one time. 1 times 11 is 11. 20 minus 11 is 9. So this is going to be a repeating decimal. It's going to repeat the same 18181818. So that is not a terminating decimal. So the correct answer choice here is B. 7 halves. Same the same. 3 and 5/10 as a decimal. So now answer choices 3 through 10. Record the letter of the fraction card that is equivalent to the decimal representation below. Not all of the cards are going to be used. So for this, I'm just going to put down the letter choices, and if you have like a specific question about it, we can go over it tomorrow. So that way we're not wasting time going through all 7 of these. So 14 hundredths is fractionally equivalent to D 7/50ths. 7/50ths. All right. 2/10ths repeating, which means 2 goes on and on and on and on forever, is the same. I know that 9 is telling me something, and 9 is always the indicator that we're going to be repeating something. So 2 I know is that numerator, so the best answer choice for this one is I. This is a terminating decimal of 8/10ths, and 8/10ths is the same as 4/5. 4/5 is the simplified version of 8/10ths. 76 hundredths, that is equivalent to 19/25ths. 19/25ths. 300ths repeating. 300ths repeating is the same as 1/33. 1/33. 1/3 is 3/10ths. 1/33. All right. 625 thousandths. 625 thousandths. This is a more commonplace decimal. It's just like a well-known fact that 5/8 is the same as 625 thousandths. Again, we got a repeating decimal here. 6/10ths, but it's 6 repeating over and over and over and over again. This is just another kind of commonly known that 2/3 C is 6/10ths, just repeating over and over and over again. And then this one where it's 3/10ths repeating over and over and over again, that's the same as saying 1/3. So some of these repeating ones are well-known fractional values, and others have that 9 as the denominator. So that's homework assignment number 2, and now we will get ready for lesson number 3 today.